A fertilizer producer was experiencing chronic episodes, not being able to meet the level of CO2 treating required for ammonia synthesis. This was resulting in substantial lost profits from lost production and maintenance costs. My name is Simon Weiland. I'm a technical applications engineer with Optimized Gas Treating, and together we'll walk through the steps taken to solve the case of the off-spec SynGas. This plant had a two-stage split-flow CO2 removal system using semi-lean and fully lean piperazine-promoted MDEA to remove CO2 from SynGas to less than 500 parts per million by volume. In order to avoid the complications of building a single very tall column, the plant had the lean section and semi-lean sections separated into two individual columns. These two columns in series each contained 11 meters of 50-5 high-flow rings. The fully lean amine flow rate was fairly low, being just enough to polish the gas before exiting the CO2 removal system. The semi-lean flow was several times the fully lean flow, and this is where the bulk of the CO2 was removed from the SynGas. The plant's initial design mandated that the semi-lean temperature be at or less than 74 degrees Celsius. Unfortunately, this proved to be unachievable, and the problem was only compounded during the hot summer months. The operators struggled to achieve a semi-lean feed temperature of much less than 84 degrees Celsius, even with the lowest ambient air temperatures, and the plant was only ever able to achieve a treated gas composition of around 10,000 parts per million by volume during this time. The packing supplier was contacted because the initial suspicion by the plant personnel was something could be wrong with the column's internals. The packing supplier felt that the cause of the plant's performance problems might be due to the semi-lean temperature. However, they were unable to explain the large effect this parameter had on the unit's performance. The plant personnel had their doubts that such a small difference in the semi-lean temperature could be causing the plant's performance problems. And this is where OGT came in. Using the ProTreat mass transfer rate-based simulator, a digital twin of the CO2 removal system was set up, and a parametric study was performed to better understand how the semi-lean temperature could affect the treating performance. This was identified to be the unit's operating curve with respect to the semi-lean feed temperature. As seen in the graph shown here, a semi-lean solvent between 8 and 10 degrees hotter is in fact causing the treating to be over 10,000 parts per million, very substantially higher than the 500 parts per million target value, and even more significant than the 10 parts per million that they should have been achieving. This difference in treating performance by having such a small temperature increase is absolutely enormous. Even more surprising is that a less than 1 degree Celsius difference in the semi-lean temperature produces thousands of parts per million difference in the treated gas CO2 content. The two graphs shown here are the temperature profiles and the vapor phase CO2 content profiles, respectively, for the semi-lean bulk removal column. The different curves indicate the different semi-lean feed temperatures, and you can clearly see from the vapor phase CO2 content profiles that as the semi-lean temperature increases, the amount of CO2 in the vapor is also increasing. The cooler semi-lean temperatures are able to keep the high heat of reaction in the lower portion of the column by quenching that released reaction heat. But as the semi-lean temperature increases, it loses the ability to quench, and the reaction heat moves further up the column, causing the solvent to lose absorption capacity. This means that at a temperature difference of 10 degrees, the amount of CO2 remaining in the gas due to lost solvent capacity increases by as much as 2 times. But what does this really mean for the top lean section that this gas is ultimately feeding? These are the same plots as shown previously, but for the fully lean polishing section. Here, you can see that the change in semi-lean temperature has a much more profound effect, and as the temperature changes from 78 degrees to 78.25 degrees Celsius, only a quarter of a degree difference, the column is no longer able to handle the increased levels of CO2 coming from the bulk removal section, and the temperature profile expands, causing the majority of the column to have an elevated temperature, and thus causing the CO2 to remain in the gas until the top portion of the packed bed. To be thorough in the investigation, the usual suspects such as crushed or defective packing, foaming, and system contamination were considered, but the simulations were not able to show the substantial change in treating performance, and no plausible reason for these failures could be found. In the end, it was ultimately determined that the reason the semi-lean amine temperatures were not able to achieve the recommended 74 degrees Celsius was due to an undersized trim cooler. And by setting up a digital twin of the absorbers using the ProTreat simulator, OGT was not only able to determine the root cause of the plant's performance issues, but was able to identify the operational curve associated with the semi-lean solvent, giving the plant operators a range of sustainable operating guidelines. The plant replaced the undersized trim cooler, and the plant was able to assume normal operations. The advice provided ultimately led to a more robust unit and saved the plant hundreds of thousands of dollars in further lost production and maintenance costs. OGT's two main products are ProTreat and SulfurPro. ProTreat is a mass transfer rate-based process simulator and is unique in its ability to accurately model acid gas removal systems, as well as many other gas treating applications. SulfurPro is our rate-based sulfur recovery process simulator. It has state-of-the-art capabilities not found in any other software for accurately modeling the modified Claus sulfur recovery process. Fully flexible flow sheets allow simulations of nearly any SRU configuration fully integrated into upstream and downstream gas processing operations. Together, these tools provide our customers with expertise in optimizing, troubleshooting, and designing units to minimize CapEx and OpEx in order to maximize profitability. We have a lot of great resources on our website at www.ogtrt.com, including numerous publications on gas treating and sulfur recovery, as well as tips and tricks to getting the most out of the software. In addition to our software products, OGT offers consulting services. To learn more, visit our website where you can see actual additional case studies from our work. At OGT, we're working for a more sustainable environment through the use of simulation tools to optimize and troubleshoot your plants, while at the same time lowering your costs and maximizing profits. We can be reached by phone or internet as shown here. Thank you for watching, and I hope that you have learned how the mass transfer rate-based simulator, ProTreat, not only identified and solved the problem, but provided sustainable operating curves, giving the plant operators more confidence and a much more robust plant design.